Hello and welcome. This activity is to help you get JASP to give you all the information you need to complete activity 8.1. In this activity, you're going to be doing an experiment in which individuals are assigned to sleep for 6, 7, or 8 hours a night for an entire week. And then they're also measuring the amount of time that they're spending on social media in those different groups. So your null hypothesis is that there will be no difference in social media use across the 3 different groups of sleep time. And obviously your research hypothesis is that that's not the case, that one or more of the groups will differ from the others. If you want a full review of how to interpret the data, you should look at my longer video that reviews the chapter. The point of this video is to help you get JASP to generate the numbers you need, and then I'll give you some base instruction on where to look and find specific numbers. But if you want to know more details on interpretation, again, you should review the entire video where I review the chapter. Okay, so you're going to run an ANOVA. I'm assuming you've already got the data in JASP. Here it is. So you're going to run an ANOVA. So you click on ANOVA and then ANOVA. Your grouping variable is your fixed factor, and your dependent variable, it goes into the dependent variable box. In this case, dependent variable is the amount of time people spent on social media. And that'll give you this ANOVA table over here, but that's not quite all we need. So we need to get descriptive statistics, an estimate of effect size. It will automatically give you an eta squared. We don't want that. We'd rather have an omega squared, so we click on that. Then you'll want to come down and click on post hoc tests. You'll want to move the variable over, and you can leave it in the Tukey check right there, and then we're good. You want to click on confidence intervals, and you might as well flag significant comparisons or not. It really doesn't matter. Descriptive plots, you'll want to move this over to the horizontal, and then we'll get a nice plot for that. It's always good to get error bars and a confidence interval. And that should be everything you need to get all the numbers for this activity. So now I'm just going to walk you through what these various outputs are. Here is your ANOVA summary table. This is the sum of squares. Some questions will be dealing with the mean square. So you have a couple mean squares. This is the mean square between treatment, or the mean square sleep group, because you had the treatment is different amounts of sleep. So that's the between treatments sleep group. That's your mean square. And then your mean square residuals is sometimes called the mean square error. If you divide, this is an estimate of error variability or sampling error. Individual differences error as well. Again, the chapter will explain it. And this is the amount of variability due to the treatment effect and individual differences and error. So if you divide this number into this number, you'll get F. And then there's your p-value. And here's your omega squared. This is the amount of, omega squared is the amount or the percentage of variability in social media use time that is explained by which group people were in. So we can explain about 5% of their total social media use time based on which group of sleep they were in. This p-value tells you that the null hypothesis is unlikely to be true. Again, the null hypothesis was that all 3 groups use social media about the same amount of time. This is a very compelling p-value that that's not the case. This should tell you that at least one of the groups used social media differently, a different amount of time, than at least one of the others. It might be that all groups are different. It might be that just one group is different from the other. You'll have to go and do post hoc tests to determine that. If the null is true, you expect to get an F value close to 1. We got an F value almost 6 times more than what we would expect if the null were true. So this right here tells us that we have pretty compelling evidence that the null hypothesis, that all groups are equal, is probably not the case. Here we have descriptive statistics. This is the mean time in minutes that people spent using social media across a week. So you can already tell that they're not exactly the same. And so now what we need to do is figure out which groups, which comparisons are far enough apart, which mean differences for each of these comparisons are bigger than what you would expect due to sampling error. Here is our plot. Clearly, it indicates that people who had the least amount of sleep, 6 hours, spent more time on social media. That trend followed for 7 and 8 hours as well, but these look like they might not be big enough to be beyond what you'd expect due to sampling error. This one kind of does, but again, we'll need the p-value to look. Now it's time to go down and look at the post hoc tests to determine again which of these groups are deviating more than what would be expected due to sampling error. So here is the post hoc test. Now, unfortunately, JASP does not give us the p-value we would like to have. It gives us a p-value for a post hoc test called a Tukey post hoc test, also known as an honestly significant difference post hoc test, an HSD. And we want an LSD, at least significant difference. So it's not hard to get, but unfortunately the computer's not going to give it to us. So we're going to have to do something slightly differently. Here is the t-value for each comparison. So in other words, the way you read this is comparing the group that got 6 hours of sleep to the group that got 7 hours of sleep. There's the mean difference in social media use. Here's a confidence interval for those mean differences. And then here's the t-value. We're going to need to use this t-value. This p-value is not the one we want. So you can't use this one. We'll have to look it up. And the way we look it up is use that p-value calculator that we used way back in chapter 5. So you're going to need to write down this t-value of 2.2909. You're write that down, and then you're going to have to enter that into the p-value calculator. The other thing you're going to need for the p-value calculator is the DF. Well, we're comparing group 6 and group 7. Those two groups each had 60 people in them. And so the DF is going to be the total number of people in the entire study for that comparison. So 60 plus 60 minus 2. So it's going to be 118. So what we need to do now is go to the p-value calculator. You can find the p-value calculator in the chapter 8 folder. P-value calculator for the post hoc test. I have a link there. If you do that, that'll come up. You'll want to enter the p-value the t-value that you want the p-value for. So it was 2.2909. And we also need the degrees of freedom, which was, again, 120 minus 2, the total number of people in the study, minus 2. So that is 118. And then it gives you the p-value that you need. In this case, we're going to be using the two-tailed p-value. So the p-value for this comparison is p equals 0.0237 and got all that stuff. So that's the p-value you're going to need for that comparison. Now, to find the other p-values that you need, you would simply enter this t-value. So it's 3.3441. Go back to the p-value calculator. Again, remember 3.3441. 3.3441. Enter. And now it gives you the p-value that you need. And then you would go back and do the exact same thing for the last comparison. That should be everything you need to complete this activity. As always, let me know if you have any questions. I hope the activity goes well for you.